Hello students, I am Tulika Banerjee. Today I bring you the next learning episode in BSc Forensic Science on an important unit of paper questioned document, that is identification of ink. In this episode, we will discuss about ink, its composition and the key ingredients. In addition to it, you will also get to know about the classification and types of inks. Moreover, you will also be studying about the systemic approach to ink identification and advancement in ink analysis. By studying age of inks and conclusion, let us have a look at the modules which we will be studying today. Module 1 is regarding introduction to ink, Module 2 is regarding composition of ink, Module 3 is key ingredients of ink, Module 4 classification of inks, Module 5 types of inks, Module 6 a systemic approach to ink identification, Module 7 is regarding advancement in ink analysis, Module 8 is regarding age of inks, and the last module, that is the Module 9, is regarding conclusion. Ink is a type of colored liquid which is used to produce colored surface in different fields like a painting, image, text or any kind of design. For the origins of ink, we have to turn to ancient Egypt, particularly the Old Kingdom. The ancient Egyptians used red pens, and by 2697 BC, the Egyptians appear to have developed ink. The ink obtained was of black in color from carbon black or from finely pulverized pin ash. These elements were then added to lamp oil, which contained a gelatin made from boiled donkey skin. Unfortunately, this meant that the ink did not smell very good. So the Egyptians added musk oil to give it a better smell. The ancient Egyptians weren't the only ones playing with ink at this time. In the 23rd century BCE, the Chinese were exploring the use of natural dyes mixed with graphite and water to produce an ink that could be applied with brushes. Indians developed ink during the 4th century BCE. It was made from burnt bones, tar, pitch and other substances. Writing was done using this ink and a sharp pointed needle. Ink is composed of solvents, pigments, dye, resins, lubricants, solubilizer, surfactant and other materials. Each component has its own importance to make it more useful. Ink composition varies but commonly involves 4 components, which are colorants, vehicles or binders, additives and the carrier substances. The earliest black writing inks developed before 2500 BC were the suspensions of carbon, usually lampblack, and water is stabilized with a natural gum or materials like egg albumin. The pigment may or may not be colored and the solvent may be aqueous or organic in nature. Modern ink formulations are rather more complex. In addition to the pigment, they contain many other ingredients in varying levels. Collectively known as vehicle, these additional ingredients include pH modifiers, humectants to retard premature drying, polymeric resins to impart binding and allied properties, defoamer or anti-foaming agents to regulate foam efficiency, wetting agents such as surfactants to control surface properties, biocides to inhibit the fungal and bacterial growth that led to fouling, and thickeners or archaeology modifiers to control ink application. Printing inks contain colors which are imparted by pigments rather than the dyes used in writing inks. Pigments are insoluble whereas dyes are soluble. Ink pigments are both inorganic and organic in nature. Most red writing inks are a dilute solution of the red dye eosin. Blue color can be obtained with substituted triphenyl methane dyes. Many permanent writing inks contain iron sulfate and gallic and tannic acids as well as dyes. Ballpoint ink is usually a paste containing 40 to 50% of dye. Most white inks contain titanium dioxide as the pigment, as rutile and anatase in tetragonal crystalline form. However, growing concerns over the known toxicity of heavy metals has led to the replacement of many inorganic pigments such as chrome yellow, molybdenum orange and cadmium red with organic pigments, which offer better light fastness and reduced toxicity. Furthermore, carbon black now replaces steel black, rutile black and iron black in nearly all black inks. In fact, the ink industry is the second largest consumer of carbon black. The main ingredients which are found in ink comprises of pigments which can be organic and inorganic in nature, dispersants such as surfactants and polymers, resins or polymers, then we have humectants, then defoamers and antifoaming agents are present, then wetting agents, pH modifiers, usually they are amine derivatives, biocides and bacteriostats. Dear students, let us now discuss each of these constituents in brief. Pigments are considered to be the chief constituent of an ink and contribute about 50% of its cost. A pigment is essentially any particulate solid colored, black, white or fluorescent that alters the appearance of an object by the selective absorption and or scattering of light. It occurs as a colloidal suspension in ink and retains a crystal or the particulate structure throughout the coloring or printing process. Organic pigments in modern inks are identified by the color index system number that reflects the color shade or hue and structural and chronological details, order of synthesis of the pigment. For example, the well known blue pigment, that is copper phthalocyan blue, is Pb15. The color intensity or the strength of a pigment increases as the particle size reduces and the opacity peaks are obtained around a particle size of 0.3 micrometers. Fluorescent pigments have a variety of applications such as in security inks to prevent forgery, in traffic light signals, poster boards and advertising. However, instead of comprising multiple layers of calcium carbonate and protein, pearlescent pigments contain flakes of mineral mica, which is usually having lower refractive index, coated with layers of titanium dioxide having a higher refractive index. Now, we will be studying about the difference between pigment and dye. A pigment is a dry powdery substance that must be mixed with a liquid like water to leave behind black, white or color. The pigment is not necessarily water soluble, but it may remain suspended in the liquid, much as is the case for a colloid. Pigment particles tend to bond to edges within the chosen medium, a reason why these inks tend to last longer and resist fading over time. Dye-based inks tend to be cheaper and water soluble. Dye ink generally takes more time to dry and results can be poor if a drop of water hit a page. Colors are brighter because various optical compounds are added to dye ink to enhance the color. However, these compounds have a low resistance to light or to UV rays, especially since dye-based inks usually spread more thinly than pigment inks on the surface. Fading can be an issue if the document is exposed to sun. The next chief ingredient in case of inks are the dispersants, comprising of the surfactants and polymers. The dispersants comprises of surfactants and polymers. The main function of the dispersant is to avoid the sticking of ink components together. The third component are the resins or polymers. The main function of the polymeric resin is to impart binding and allied properties. Next are the humectants. These are the substances which retard premature drying of ink. The next ingredients are the defoamers and anti-foaming agents. These agents help in regulating the foam efficiency. The next ingredient that we have is the wetting agents. The wetting agents such as surfactants control the surface properties of the ink components. pH modifiers, which are usually amine derivatives. The pH modifiers helps in stabilizing the pH of the ink. And lastly, we have the biocides and the bacteriostats. Biocides and bacteriostats are used to inhibit the fungal and bacterial growth that lead to fouling. Inks generally fall into three classes: aqueous, paste and powder. The liquid that carries the colorant water is referred to as aqueous inks. Water-based inks come in two varieties, that is dye and pigment. Dye ink is water dissolved in color as they are cordials and are best in use. The colorant which is used in dye has a tiny size and allows a very small dot size which provides detailed images with a smooth tone. Dye ink will fade in UV light, and if water is poured onto a dye, the colorant dissolves in the water again and washes away or runs. So, dye inks are not waterproof. Next, we have the properties of ink. Ballpoint ink is specially formulated to be thick and fast drying. Its viscosity is precisely controlled. It must be as thick as possible, but still thin enough to flow down the barrel of the pen in response to gravity. Ballpoint inks use dye as the tiny particles of undissolved pigment can clog the ball of the pen. Ballpoint pen ink is usually oil based to give the required thickness. The ballpoint pen ink dries quickly because it is oil based and is permanent and water fast. Fountain pen ink is a water based ink dye intended for use with fountain pens. Red ink usually contains the eosin dye, whereas blue ink often contains triaryl methane dye. Gel pen ink is a pigment suspended, that is the colloidal form, in water based gel, and it is opaque and thick in appearance. First of all, we have the Indian ink. It consists of amorphous carbon in the form of lamp black made into a cake with hide glue. The color of this ink, which can vary from dark brown to blue or black, is governed by the quality of the lamp black, which again depends largely upon the materials from which the lamp black is made. The second category that we have over here is fountain pen ink. It can be divided into blue-black permanent. This is a record in which it contains about half the normal concentration of iron compounds with an increased proportion of dye stuff, and The non-staining, it consists of no iron salts and is a little more than a dilute aqueous solution of one or more synthetic dye stuff. Next we have the ballpoint pen ink. This ink is based on polyethylene glycols of suitable viscosity. They are non-hygroscopic and its dye stuff is of high tinctorial powder. The next type is logwood ink. It is obtained by mixing chromium salts with an aqueous extract of logwood chips. Iron ball ink. Iron ball ink is a purple, black or brown black ink made from iron salts and tannic acids from vegetable sources. The documents which are alleged in case of forgery and alterations are frequently requiring ink examination, and while doing so, the criminal or forger is not generally aware of the fact that the inks of similar colors are not always identical in their compositions, and mere resemblance in the color of ink has little significance. Before starting the examination, one should always apply non-destructive methods in examination of ink because it can preserve the original sample and that can be further examined. So, first we have the physical examination. This includes the optical examination of ink with the help of hand magnifier or compound microscope to determine first, the type of ink used, whether it is a ballpoint pen, fountain pen or a fiber tip pen, etc. Then the color of ink. Then comparison of secondary color shades. Example, ultraviolet rays are used to compare the degree of fluorescence. Then we have infrared rays. They are used to differentiate between dyes and pigments and especially the ballpoint pen inks. After physical examination, we have the chemical examination. The chemical examination for ink is carried out to know the composition of ink. Physical examination helps in ascertaining the physical factors such as color, shade of particular ink, the thickness of a stroke, indentation on the back of the paper, etc. The chemical analysis of ink can be conducted in two different ways. First, performing chemical spot test on the punctured or punched out fragments of ink strokes or on the ink strokes itself. And second, chromatographic analysis for isolation and characterization of various dye stuff inks. The chemical spot test. Prior to advanced techniques, the ink was chemically analyzed and differentiated by chemical spot tests performed on the ink itself or on small fragments of ink strokes punched out from the ink line with the help of a scalpel hypodermic needle. Nowadays, these chemical spot tests are replaced by the TLC technique or thin layer chromatography and other sophisticated techniques. However, some cases the spot test may prove useful for conducting preliminary examination. Numerous reagents have been suggested by different workers for performing the spot test. The following reagents may serve the purpose: bromine water, saturated aqueous solution, sodium hydroxide, that is 2 normal aqueous solution, hydrochloric acid, that is 2 normal aqueous solution, stannous chloride, that is 10% aqueous solution, sodium hypochlorite, that is saturated aqueous solution, oxalic acid, that is 5% aqueous solution. Carbon inks can be distinguished from other writing ink as this ink remains unaltered by the action of reagents. Logwood ink and iron nutgall inks can be differentiated with hydrochloric acid test. The logwood inks with these reagents give red or purple, that is red color reaction, whereas the iron net-gall inks give blue or blue-green reaction. Nigrosin inks can be differentiated from the logwood and the iron net-gall inks with oxalic acid test. The oxalic acid has little effect on nigrosin, whereas this reagent bleaches the iron net-gall inks to some extent, or it may change color of logwood and iron net-gall inks. Next, we have the chromatographic analysis of inks. Chromatography is based on the fact that sample distributes or partitions itself to different extents in two different immiscible phases, which is described by the partition or distribution coefficient Kd, where Kd is equals to concentration of sample in phase A divided by concentration of sample in phase B. Thin layer chromatography or TLC is considered to be the most suitable technique for isolating and identifying various components of ink. In these techniques, a thin layer plate is prepared by coating a glass plate with silica gel or aluminum oxide, but the ready-made silica gel G plates are also available in the plate form and in market. Depending on the amount of ink deposited on the paper, 1 to 10 plugs of ink are removed with the help of a spatula or hypodermic needle, and the ink is dissolved in the minimum quantity of a suitable solvent. A few microliters of the solution are spotted with the capillary tube onto the layer on the thin layer plate, and plate is then placed in a closed jar having selected solvents in fixed ratios. The liquid slowly begins to rise up the plate, and when it moves on the sample spot, the components of the sample get separated and get located at different positions depending upon their affinity. When the liquid phase has moved a sufficient distance, the plate is removed from the jar and the RF value of different spots are recorded. For differentiation of two inks, their spots are marked on the same TLC plate, and if these samples show same number of spots with the same RF values and colors, then the two inks are identical in their dye composition. Otherwise, they indicate the difference in ink. RF value is defined as the distance travelled by the component divided by the distance travelled by the liquid mobile phase. The different solvent systems for ink analysis includes butanol is to ethanol is to water in the ratio of 50:15:10. The next solvent system that we have is ethyl acetate is to cyclohexane is to methanol is to ammonia in the ratio of 70:15:10:5. Then we have ethyl acetate is to butanol is to ammonia in the ratio of 50:35:5. Then we have ethyl acetate is to ethanol is to water in the ratio of 70:35:30, and a solvent system of toluene is to acetate is to ethanol is to water in the ratio of 30:60:7:2. The most commonly applied method for ink examination is optical and spectrometry methods. The absorption and luminescence properties in visible and infrared light of the ballpoint pens can be examined with a system of filters by light of a specified wavelength from 600 nanometers to 1000 nanometers. The VSC or the visual spectral comparator is most suitable instrument for examination of it is inbuilt with a spectrometer, so that examination by means of absorption spectrometry in the visible and the infrared light range are also carried out. While measuring the absorbing of light or the absorbance of light, a wide standard sample is used which reflects in full the electromagnetic radiation of length of 4 to 1000 nanometers. And the comparison is done between the amount of light being absorbed by the ink on paper and the absorption of light by the standard sample. For each sample of ink, absorption measurements are made, and then the obtained spectra were averaged and arranged in pairs for comparison. Module 8, Age of Inks. Age of the ink can be determined. It can be helpful in understanding the age of the document. The aging of ink is governed by a number of environmental factors such as aerial oxygen, light, temperature, humidity, and internal factors such as the nature of ink, width of strokes, and the nature of the paper bearing the ink, etc. It is not practically possible to determine the degree of effect of the environmental factors on a given specimen of ink. A document enclosed in a closed polythene envelope and kept in a closed cabinet will age at a much slower rate than if the same document is exposed to light, temperature, air, and humidity. The reason is obvious. Number of methods affects it, such as change in color of inks, solubility of inks, amount of ferrous in iron glutinate inks, and iron migration, etc. Presently, no method has been fully successful to determine the absolute age of inks. Module 9, Conclusion. Age of the ink can be determined. It can be helpful in understanding the age of the document. The aging of ink is governed by a number of environmental factors such as aerial oxygen, light, temperature, humidity, and internal factors such as the nature of ink, width of strokes, and the nature of the paper bearing the ink, etc. This topic is of real relevance during the examination of questioned documents and while we want to infer the age of document also. Dear students, with this module of conclusion, our chapter comes to an end. I hope you all have enjoyed this chapter and gained valuable information regarding identification of ink. I am sure you all have understood the central basis idea behind this module. Do keep in mind what we discussed today. I'll be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQ, quizzes, LORs, etc. Make sure you revise the modules frequently so that you master the topic well and take up the exercises. Thank you for your time today. I'll see you in the next lecture. Keep learning, work hard, and do revise the chapter. Goodbye.